Good morning, Anandal. Today I am here to give a presentation on mechanical behavior of composite structure. So, so without getting delay, now let us discuss or get into topic. Introduction. Uh, so now let us discuss about the introduction. There is a unbased request of a new material which will satisfy the specific requirements for various applications like structural, medical, household, industrial, construction, transportation, electrical and electronic, etc. Metals are the most commonly used materials in the application. In the year of time, there have been specific requirements on the properties of this material. It is impossible for any material to fulfill all these properties, hence new materials are developed. In the following lecture, we will introduce the composite materials, mechanical behaviors, and etc. Now let us discuss about the definition of a composite material. A composite material is defined as a material which is composed of two or more materials at a microscopic scale and has a chemically distinct phase. Thus, a composite material is a heterogeneous at a microscopic scale but statistically homogeneous at macroscopic scale. The materials which forms a composite are all called the constituents or constituent materials. The constituent materials of a composite have significantly different properties. Further, it should be noted that the properties of the composite form may not be obtained from this constituent. However, a combination of two or more materials with significant properties will not suffice to be called as a composite material. In general, the following conditions must be satisfied to be called a composite materials. The combination of materials should result in significant property changes. One can see significant changes when one of the constituent material is in platelet or fibrous form. The content of the constant is generally more than 10%. In generally, property of one constant is much greater than the corresponding property of the other constants. The composite materials can be naturally or artificially made materials. In this following section, we will see the examples of these materials. For example, a material which need high fatigue life may be not cost effective. So a manufacturer will always tend to manufacture product according to mechanical properties which they are supposed to need, or depending upon the requirement of the application. And now let us discuss the different requirement of the applications is given below. That is strength, stiffness, toughness, high corrosion resistance, high wear resistance, high chemical resistance, high environmental degradation resistance, reduced weight, high fatigue life, thermal insulation or conductivity, electrical insulation or conductivity, acoustic insulator, radar transparency, energy dispersion, reduced cost, attractiveness. So now, before getting into topic, I was supposed to discuss about the mechanical properties, because in order to understand the mechanical behavior of composite structure, we should supposed to know what are the mechanical properties which are present in our daily life or which are presented. So let us discuss about the different types of properties. The important mechanical properties of a material are as follows. Strength. It is the ability of a material to resist the external applied force without breaking or yield. Stiffness. It is the ability of a material to resist deformation under stresses. The modulus of elasticity is a measure of stiffness. Next, elasticity. It is a property of material to regain its original shape after deformation when the external force are removed. This property is desirable for material used in tools and machines. Plasticity. It is a property of material which retains the deformation produced under load permanently. This property of a material is necessary for forging in stamps, coin and in ornament work. Ductility is a property of metal enabling it draw into wire, and brittleness is a property opposite to ductility. It is a property of breaking with a little permanent distension. And a malleability is a property in which by the external weight or by the external force we can able to suppose it to be in rolls, in sheets. And the toughness is a property of a material to resist fracture due to high impact loads like hammer blows. And next, resilience is a property of the material in which it absorbs the amount of energy. And creep is defined as when a pot is subjected to constant stress at high temperature for a long period of time, it will undergo a slow and permanent deformation called creep. And next, fatigue. Fatigue. When a material is subject to repeated stresses, it fails at stress below the yield point stress. Such type of failure of a material is called fatigue. Ordinacity is a very important property of a material and has a wide range of meanings. It embraces many different properties such as wear, resistance to wear, scratching, deformation, and machinability, etc. It also means the ability of material to cut another material. So now we had discussed about the mechanical properties. We can discuss the general mechanical properties. Now we will discuss different mechanical properties of composite material. The mechanical behavior of composite materials can be assessed with the help of mechanical properties of composite under loading, different loading. Now let us discuss it. Tensile strength. In composite materials, the tensile strength depends on the volume of a fiber reinforced material and the type of reinforced material. The composite materials can withstand high tensile loading if the fiber reinforced material is of high tensile strength. For fiber reinforced composite, the unidimensional tensile strength has good value. Hence, sigma C represents the tensile strength of composite, sigma M represents the tensile strength of base. Hang on a minute. Next, the value of tensile strength depends on the structure of fabrication, like laminate type, particular reinforced type, and the deformation characteristic of composite materials depend on the loading direction. Elastic modulus. The structure of the composite materials in the form of laminate can be formed with the help of fiber reinforced and material matrix. The value of Young's modulus of complete composite materials can get with the help of different expression. The expression is given below. In this figure we can able to understand here, it is supposed to be different material, and in which EC represents the Young's elastic modulus of composite materials. EM represents the elastic module of material matrix, and EF represents the elastic module of fiber reinforced. And now let us discuss about the compressive strength. The compressive strength of unidirectional fiber reinforced composite, where fiber responds as an elastic column, used compressions and failure of the composite materials would take place by buckling phenomena of the fiber reinforced, can obtain by giving the formula. Here sigma C represents the comprehensive strength of composite, D represents the diameter of fiber, and L represents the length of the fiber. The buckling of fiber reinforced in a composite under comprehensive load can be seen in the image below. This is the image in which we can able to understand this. And next, let us discuss about stiffness. The fibers in the composite materials are made up of elastic material which good stiffness property and high stiffness values. The stiffness of a matrix material is less than the stiffness of fiber. So the composite materials has a good stiffness. Temperature resistance. That the resistance of a composite materials against high temperature is also good. The composite material can be used to make equipment that is required to operate in high temperature zones. Corrosion resistance. The composite materials have high resistance against a corrosive environment where they can be readily used. Pure metallic or alloy cannot be durable in a high corrosive environment. The matrix material, base material, prevents the composite from the comprehensive material. And next, crack propagation. Whenever cyclic load acts on a composite material, then there would be the possibility of fatigue failure. Due to this, the initiation and the propagation of crack occurs in the direction perpendicular to the load axis. Further, the crack propagates and the failure of a composite takes place. Stress concentration. Whenever defects are present in the composite material, stress concentration starts taking place at the point of the defect. Due to this, the mechanical properties of composite materials get hampered. Furthermore, the failure of a composite materials take place. Thank you. This is the reference slide and the main slide is here. Thank you for everyone.